Okay, so for our last problem, basahin natin yung problem. So the aluminum and bronze cylinders are centered and secured between two rigid end plates by tightening the two steel bolts. Okay? So ito guys, ito yung steel bolt. Ayan, meron siyang dalawa. And then sa gitna niya, meron siyang assembly na aluminum and bronze rod. So sinasabi dito, there is no axial load in the assembly at a temperature of 50 degrees Fahrenheit. So the initial temperature given as 50 degrees Fahrenheit. So walang stress na nangyari. Ano? So find the stress in the steel bolts when the temperature is increased to 200 degrees Fahrenheit. So as you can see, nagkaroon ka ng increase in temperature. So you will have an idea na rin na etong mga material sa loob and even yung steel rod natin will deform or yung deformation to be specific, mag-expand siya or mag-elongate. So ito, parang tutulak siya. Ano? And then, the reason why rin siguro kaya steel bolt yung nilagay sa dulo as a support. Kasi yung kanyang alpha is less compared sa bronze and aluminum rod. So yung thermal deformation niya is minimal compared dun sa dalawang material. Okay, so hindi siya basta-basta mag-elongate. Kumbaga na serve niya yung purpose niya na pigilan yung pag-expand ng aluminum and bronze. So again, the required in this problem is to find the stress in the steel bolts. So guys, ang gawin natin dito, mas maganda if mag-section tayo. Hatiin natin siya ng ganyan. Okay, so ano ba yung makikita natin? So, ang plate, ito yung plate natin. Oops. Again guys, ito yung ating dalawang steel rod. Okay? So, yung aluminum and bronze will cause a force going to the right. Kasi nga ano niya, parang gusto niyang kumawala Kasi do sa kanyang increase in temperature, humaba siya, nag-expand. So again, yung purpose again ni steel is to prevent yung paghihiwalay nung assembly natin. Okay? So I will name this as my P steel. Okay? And then ito, I will let this as my P aluminum plus P bronze, or ilat na lang muna natin siya as P. Okay? So yung P mo is just equals to sa P aluminum plus P bronze. Okay? So next, so yung assembly natin, if i-consider mo yung other side. Okay? So ano yung magiging itsura niya? So, ito, hindi ko na lang i-drawing na sa gitna ha. Hindi nagpalit yung kulay, no? Ayan. So, pantay natin siya dito. Okay. So, free body diagram lang siya. Hindi siya katulad ng atulan. So, considering the equilibrium equation, considering this FBD1, na siya as FBD1. And then yung baba, I will name this as my FBD2. So, considering the free body diagram 1, let's take summation of forces in the x direction. Okay, so assuming all to the left forces is positive. So 2p steel is just equals dun sa p. Or yung p steel mo is just half of p or yung sum ng aluminum tsaka yung bronze. Okay? So, the compatibility equation, again, ganito nga yung mangyayari. Nung sinection natin, or parang inalis natin yung support sa kanya, hinayaan natin mag-expand yung mga materials natin. Ano? So, because of the temperature change, again, yung inyong aluminum and bronze will expand. Okay? So, pag pinagsama mo yan, sabihin natin na hanggang dito siya. Okay? So, ito yung magiging thermal deformation ni aluminum at saka ni bronze. Okay? Okay? So, next, considering na yung steel, sasabi ko nga kanina, di ba, hindi naman na ibig sabihin na steel yan, hindi na siya maapektuhan ng change in temperature. So, syempre, magde-deform pa rin siya. Okay? So, again, ang ating direction dito ng steel is going in this direction. Ngayon, ang kino-consider na natin is yung free body diagram number 2. So, kung pag ganito yung steel, para maging equilibrium, ayan siya. Okay? P-steel natin yan. Okay? P-steel, P-steel. Ngayon, ito yung para sa aluminum and bronze. So, ang gagawin ko dito ko na lang i-drawing sa baba yung magiging effect nung actual force kay T at saka yung change in temperature. Okay? So, unahin ko muna yung P-steel kasi nga, this is going in this direction. So, mag-elongate yan. Okay? So, sabihin na natin na hanggang ganyan yung displacement niya. So, this will be, or yung haba nito, gagawin ko na lang siya na green. So, yung haba na yan, so ito guys is yung actual deformation of the steel. Next. So, nung narating niya yung point na to, so, i-apply naman natin guys yung magiging effect ng temperature. So, sabi ko nga, unlike dito sa dalawang material, hindi siya ganun kalaki compared nga dito. Kasi nga, based on the properties, mas madaling mag-elongate yung aluminum and bronze. So, sabihin natin kung mag-expand man yan, hanggang dito lang siya. Okay? Nag-assume lang tayo. Okay? So, ito, I will label this as my ito yung deformation due to the temperature of the steel. Ngayon. Okay? So, anong nangyari ngayon? Ito yung magiging final position. Okay? So, coming from this point, initial position, ng lahat ng mga materyales, ang gagawin natin, ito yung magiging final position niya. So again, ano nga yun? After mo ma-remove yung support, hayaan mo mag-expand yung mga materyales. Ngayon, ang goal naman nito is paano mo siya maibabalik dito sa position na to. Okay? So that's why, nung nag-expand yung material natin dito, sorry, ito pala yung magiging final position natin. Ano? And then ito, ito yung magiging bago or yung magiging IP na natin ngayon. Ano? So, para maibalik mo dyan o mapapunta mo dito coming from this final position and then maipapunta mo siya dito. So, dapat, ano na lang ba yung wala? So, ang wala na lang dyan is yung force required for the aluminum and bronze considering na actual force sila. Okay? Or in short, ganito yung mangyayari. So, kung nandito na siya, dapat magpanagpo sila dito. Ano? So, gawin natin tong IP prime. So, kung nandito yung aluminum and bronze, so dapat yung magiging deformation natin due to the actual force is pabalik. Ano? Or, this will be your delta P for the aluminum plus yung delta P for the bronze. Okay, so siguro nagkaaroon ng idea ano yung magiging equation natin dito. Therefore, based dito sa ating figure, the compatibility equation will be delta T of the aluminum plus yung delta T of the bronze. So that is equals lang sa eto. So delta P of steel plus delta T of the steel and then plus kahit pabalik yung displacement niya, okay lang yun. Or kung gusto nyo, i-subtract nyo na dito. Ilagay nyo dito sa side ng equation na to. So, delta T of aluminum and bronze minus delta P of aluminum and bronze. Pero kung ano yan, dito na lang natin isulat. Kasamahan ng mga to. And then, plus delta T P of aluminum then plus delta P of the bronze. Ayan. So guys, given naman dyan yung mga material properties natin, ang gagawin nyo lang dyan is, substitute nyo lang yung mga values na nakuha natin dito. But if you're going to observe the figure, ano ba yung magiging length? Lagyan natin dito ng L of the aluminum rod. So ito, this is 3 inches as shown in the figure. Yung bronze mo, so that is 4 inches. And then yung steel rod, kung mapapansin nyo, naglagay siya ng 1. So ibig sabihin yung total length ng steel bolt is 3 plus 4 plus 1 plus 1 or 7, 8, 9. So that is 9 inches. Okay? Ayan. So, alpalat, temperature of aluminum. So, unahin natin to. So, that is 12.8 times 10 to the negative 6 times yung length na 3. And then yung change in temperature. So, that is, yung delta T natin is, di ba, final minus yung initial. Or that is 200 minus 50. So, gawin ko na lang. Diretso ko na siyang 150 So, times 150. Okay? And then plus, yung para sa bronze rod natin, bronze cylinder pala. Nasaan yung bronze? So, 10.5 times 10 to the negative 6 times yung length na 4 and then 150. Tapos, dito ko na lang ilagay yung equals So, para sa steel, yung plae, from which, yung steel natin is, find the stress. Ilet na lang muna natin siya na P over 2. Okay? Kasi ang hinahanap is yung stress developed in each material. Okay, so let me just correct the assumption that we made in here in the free body diagram 1, yung equilibrium equation. So as you can see, nilagay ko yata dito, or nilagay ko dito that yung P is just equals to P aluminum plus P bronze. So I will just correct this. Eto. So pawiin ko lang to. Ayan. So this is not plus, but it is more of equal. Okay? So maalala niyo yung mga example natin previously and even do sa topic na stress. Kung gagawin mo kasi siya ng free body diagram, di ba ito? Kung i-consider mo yung cover, parang ganito yung nangyari. Ayan siya. Ngayon kung i-consider mo yung assembly ng aluminum and bronze. So pag ganyan siya. Ano? So yan yung P. Ngayon kung mapapansin nyo, wala naman kasi dito mga naka-apply na 2P or any value. So ibig sabihin, kung magse-section ka dito, ayan. Kung magse-section 1 ka and section 2, nabagal na naman. I-close ko lang Then re-open ko ulit. Ayan. So, kung magsasection ka, dito sa portion ng bronze, di ba kung 7, yung P sa bronze is equals lang din sa P. And then, kung sa aluminum yan, since wala nga ring ibang naka-apply na load, so kung P yan, so yung P aluminum mo will be equals lang din sa P ng bronze. Okay? So, I know, nagets yung sinabi ko. Okay? So, sige, wag na natin burahin. Ano? So, pakita ko na lang din dito. So, ito is magiging P ng bronze. And then, ito will be for the P aluminum. Ano? So, kung mag-section, sige, gawin ko na lang tong section A and section B. So, when you consider section A, yung P, bronze, is just equals to sa P. Okay? And when you consider section B, yung P aluminum mo is just equals lang sa P. So, kaya ito yung magiging equation natin dito. Clear? Alright. So, balik tayo dito. So, simulan na natin sa part na to. Ano? So, the delta due to the actual load P for the steel. So, ang sabi nga doon sa P steel, yung value ng P niya is P over 2. So, gamitin na lang natin yon, P over 2 for the steel. So, N, di ba? So, multiply by natin ng 9. And then divided by yung area, which is given naman dito sa table, which is 0.75. So, check nyo lang yung mga unit ha. Dapat inches lahat. And then E, so 29 times 10 to the 6. Okay? And then plus yung sa thermal or yung alpalat, so that is 6.5 times 10 to the negative 6 multiplied by L, so that is 9. And then multiply by 150. And then, sunod, yung para sa actual strain caused by the aluminum, or strain caused by the actual force for the aluminum. So that is Pla also. So yung P aluminum natin is equals lang sa P. Okay? Then multiply by the length of the aluminum rod o aluminum cylinder. So multiply by 3 all over area na 2 times 10 times 10 to the 6. And then last will be for the bronze. So again, yung P ng bronze is equals lang sa P. Multiply by 4. And then yung area, so that is 3. And then that is 12 times 10 to the 6. Okay? So from this equation, mahahanap natin yung value ng P. So open lang natin yung calcu. Ayan. So encode lang po natin. So that is 12.8 times 10 to the negative 6 times 3 times 150 plus 10.5 times 10 to the negative 6 and then times 4 times 150 and then equals to, let na lang nating x, so divided by 2, so times 9 divided by 0.75 and then divided by 29 times 10 to the 6. Check lang natin na. Negative 6 at saka 6. Okay. And then plus 6.5 times 10 to the negative 6 and then times 9 and then times 150. And then plus x, haba no, times 3 divided by 2 and then divided by 10 times 10 to the 6. Check na lang ha, baka nagkakalitan na yung code. Then plus x times 4 divided by 3 and then divided by 12 times 10 to the 6. Then shift, solve. So lagyan lang natin ng positive value. Sabihin natin 10. Okay. So the answer is 7019.0 1158. So this is in pound. So, ibig sabihin yan, yung answer natin for steel will be half of that answer. Or that is, divide lang natin ng 2. So, nasan yung calcu? So, divide 2. So, 3509. So, guys, yung P steel is just equals to P over 2. Or that is equals to 3509.5579. 5579 pound. And then yung P, so that is equals lang sa P aluminum and then P bronze, which is 7019.1158. So ano bang hinahanap? Find the stress in the steel bolts. So yung nakuha nating sagot for P steel, i-divide lang natin siya nung area. So the stress in the steel bolts is just equals to P of steel over area ng steel. So that is 3509.5579 then divided by the area of the steel na 0.75. So yung answer natin, so answer divided by 0.75. So that is 4679 4106. So this is in PSI. Okay? So guys, in case ipahanap sa inyo yung stress in aluminum and bronze, so madali lang din naman. So yung mga nakuha mong value dyan, i-divide mo lang ng kanyang corresponding area. Okay? So guys, again, I'll give you 3 minutes to copy the solution. So you may start copying. So guys, if you're going to observe this, paano rin kasi natin nasabi na yung aluminum and yung bronze is papunta doon or magko-compress? Kasi imagine, if hindi mo ka naman kasi tatanggalin to, ang mangyayari nga niyan, since sobrang expand yan, anong develop dito sa bronze and aluminum, kapag na-reach niya yung 200 degrees Fahrenheit, is compression na. Ano? So parang tumutulak na siya yan. And dito sa steel bolt mo, so syempre, yan yung pumipigil. So, nag-undergo siya ng tensile stress. So, ang ano natin dito is, yung stress in steel is under tension siya. Ano? And then, while for the bronze and aluminum, so siya, nag-i-expand siya. Pilit siyang, ang gusto niyang tanggalin tong mga type na to. Yung mga plate na yan. So, nag-undergo na sila ng compression. Kaya kung mapapansin niyo dito, papasok siya dun sa ano. Okay? So, ano lang yan, ang ano dyan, technique, parang imagine nyo lang na kayo yung material na yun. Ano? Pwede kayo mag-set ng mga values. Ano ba yung mga ano ko? Pwede mo nga i-check ito eh. So, paano ko nasabi? Yung alpha mo kasi, kung mapapansin nyo, mas maliit yung sa steel bolt compared to sa other two material. So, kung hindi ka maniwala, salpaan mo ng value. For example, 30 degrees Fahrenheit. So, I'm sure naman na mas malaki yung makukuha mong value kay aluminum and bronze compared to kay steel bolt. So, in short, mas madali silang mag-expand. Kagaya nito. Ito yung pinapakita niya dito sa FPD2. Okay? Okay, guys, so that ends our discussion for the topic of strain. So see you guys in our next video lecture.